We've already seen that exception objects can contain important information. For example, when we did our illegal argument exception with the radius, we included a string during construction of that object that said radius cannot be negative. And that was an important description describing what exactly was wrong that the user could then see and print out and understand what went wrong and why the exception occurred. It turns out that there's far more valuable information than just that in these exception objects. The throwable class in Java actually provides methods that we can use to get much more information regarding the exception that occurred. And we're going to see an example of that on the next slide, where in fact we use the print stack trace to actually show exactly what happened and why it happened and what went wrong. We aren't actually going to try running this program in Eclipse, but we're just going to talk about the code for it here. This is a class called testException to illustrate what we can do with the print stack trace method. So in this code, what we're going to do is actually deliberately create an out of bounds exception by accessing an element beyond the end of our array. To do that, we're going to add together some integers, and we're going to use the sum command to do that. So we're going to say sum of new int, and we're going to initialize those new integers, that array of new integers, to the integers 1, 2, 3, 4, and 5. So notice there are 5 elements in this array. The indices of these elements are actually 0, 1, 2, 3, and 4. Note the indices do not go all the way up to 5. So in our try block, we're going to call this sum function, which adds together all the elements in the array and reports their sum. When we call that method, it could generate an exception, which is why we have it in a try block. And if it does generate an exception, we're going to bail out of the try block. Not that there's any more lines of code to do inside of there anyway, but I guess we could argue that the print line statement part of this statement will not execute because we're actually going to bail out while we're trying to calculate the sum. So there's nothing to print. So in fact, we are bailing out early, and we're going to do the catch block and then process the exception. So we're not going to see the sum get printed, not even an attempt at printing the sum, because we bail out and we do the catch block instead. The method sum at the bottom part of the slide is where the exception can occur. So we start by having a running total result that we initialize to 0. And then in a for loop that should iterate precisely 5 times, generating indices from 0 to 4, we're going to add to the result incrementally the next item in our list. However, if you take a close look at the red part of the for statement, you'll notice that where we should have strict inequality, we should be saying I is strictly less than list.length, so that the indices will go from 0 to 1 less than 5. We're going to go all the way to 5 because we actually put in less than or equal to, and that is a problem. That's going to generate an exception because what will happen is on the last iteration of this for loop, I will be equal to 5, and there is no list sub 5. There's only a maximum of list sub 4, which is the number 5, but the index for it is actually 4. So we're going to iterate with I going 0, 1, 2, 3, 4. And in doing so, we've added together 1 plus 2 plus 3 plus 4 plus 5. And then we're going to try to add a 6th element that's not there. And at that point, I is too big. We're going beyond the end of the array. We've exceeded the bounds of the array, and we are going to get an array index out of bounds exception, which is a subclass of exception. So we're going to then throw an exception at this point. It's going to be caught by our catch block, and all the catch block does, you'll notice, is it takes the exception that was thrown, which is called EX, and it does a dot print stack trace. It executes the print stack trace method on the thrown object EX. That will generate the output that you see in blue on this slide. So in other words, it's going to print a little line that says java.lang.array index out of bounds exception colon 5, meaning that some index got out of bounds when it reached the value 5. And then it says under that at testException.sum, that's test exception is the name of our class that we're running, and sum is the name of the particular method where the test exception occurred, and we see then test exception.java 14. So that's actually telling us that it's in line 14 of test exception, and that would be where this index below the for loop is. And then we also got a message that says at testException.main, meaning in the main routine at line 4 in testException.java. So if you count down from the top, we have 1, 2, 3, 4 lines. That is the sort of the middle of the system.out.println statement where we're adding together the sum of the integers. So it's telling us that's from the perspective of the try block, that is where the exception occurred, but more particularly it was actually coming from line 14 where we tried to say result plus equals list sub 5, which is problematic because 5 is too big for that array. So as you can see, all of that information that you see in blue comes from the thrown exception object. So it contains much more than just a simple string like we saw in our case of the illegal radius for problem that we looked at. There's actually much more in there, much more useful information. To conclude this unit, we're going to finish off with the concept of rethrowing exceptions. Sometimes you can catch an exception and begin to process it, but it turns out you can't complete it because maybe you're missing some information that you need to know in order to complete processing the exception. When such things happen, you have the ability to rethrow the exception. So if you take a look at what happens here, we have a try block with some statements in it. Obviously, an exception can be thrown within those statements, and if it is thrown, we can catch it in the catch block. Catch block is looking for a particular exception called the exception. So there's some particular exception object that we're expecting can be caught here. And when we do catch it, we call it X. We give it a name, EX. And now we might try to process it, and before exiting we do a number of things perhaps to process it, and that could be printing off some particular error messages and trying to tidy up some things and so on. But at some point it becomes clear that we need to depend on our caller, the method that invoked us, in order to finish, because perhaps, and we've talked about this before, maybe what we need to do to finish off depends on who called us, and we can't tell how we were called and who called us, so we throw it back at our caller, and then that's called rethrowing the exception. So we do have the exception object, it's called EX, so we simply throw EX, and now our caller has to finish off dealing with it. So we've done what we can, but it's up to our caller to finish. That then concludes this unit of Module 2.